hello again, everyone. So I hope you're all guys having a good day. So for today, we have our next lesson for the application of differential equation is the mixture problem. So for the mixture problem, we have here a tank. Okay, that is a tank, and then of course the tank is containing a solution. Okay, so there's a solution. Remember, if we said a solution that is composed of a solvent and a solute. Okay, so the tank now, so of course there's a solution inside the tank, but at the same time, there's a solution intake, or a solution is going in the tank, but at the same time, the tank is also draining the solution. Okay, so the solution intake can be another solution or different solution from the solution inside the tank. Okay, so that is the idea of the mixture problem. So mostly what we are looking here is the amount of solute. Okay, we'll be focusing more on the amount of solute at any time t on the inside of the tank. Okay, so the amount of solute at any time t inside the tank. So that is mostly what we are looking for here, or what is mostly required for the problems. So I got here three cases. We have case 1, 2, and 3. Then we have different conditions for each one. And I already gave you this is the formulas for the case, for the three cases. Now, in case you're wondering why I didn't derive it, because the derivation of these formulas, though I know the formulas, the derivation of these formulas, however, it will take maybe around 1 hour. I'm not sure, but it will take a long time. Okay, maybe this video will take maybe around 1 hour if I will discuss to you the derivation of this formula. However, I guarantee you that these formulas are the right formulas for this one. Okay, so I will now discuss the first case, the case one. Case one is we have, before that, we have here the symbols that I will be using. We have T for the time, so initial amount of solute for the XO, and X is the final amount of solute, and rate in of solute is our RI, rate out of solute is RO, and the V is our volume. Okay. So for the case one, we have Ri and Ro. So that means the rate in and the rate out are just equal. And we have an intake of pure water. So remember, if we said pure water, that means that is 100% solvent and 0% solute. Okay. And that will become X is equal to XOE raised to RO all over V times the time. For the case 2, the intake is still pure water. However, the rate in and rate out are no longer equal. So there's the formula. For the case 3, we have Ri and Ro are still equal, are equal again. However, the intake now is no longer a pure water. So it can be, let's say, an alcohol or whatever kind of solution, as long as that is not a pure water intake. So there are the formulas. So with that, I'll be showing you some sample problems to show you how to use these formulas. So let's get into it. Okay, so let's have our first problem. So we have a tank contains 1,000 liters of brine with 15 kilogram of dissolved salt. And then pure water enters the tank at a rate of 10 liters per minute, and the solution is kept thoroughly mixed and drains from the tank at the same rate. How much salt is in the tank after 20 minutes? So of course, first of all, let's write all down the given as much as we can. Given. So we have a tank contains 1,000 liters. So remember that the unit liter, that is a unit of volume. Therefore, we have the first given, which is 1,000 liters of brine with 15 kilogram of dissolved salt. So remember that salt is dissolved. So it's not actually powderized. It is dissolved within the brine. So 15 kilogram of salt. So with that, we can say that a tank contains 1,000 liters and then 1,000 liters of brine. So that brine is the solution. So we can say that the 15 kilogram of salt, let's say that, for example, we have a salt water. So for salt water, that is a solution, right? So salt water is a solution. Therefore, salt will act as a solute and then water will act as the solvent. Therefore, in this case, salt is the solute. So 15 kilogram, that is the amount. Again, salt is the solute, and the amount of salt is 15 kilograms. Therefore, that will be your XO, or that is the initial amount of solute. So we can have that XO must be equal to 15 kilogram. Okay, then pure water enters the tank at the rate of 10 liters. So enters, the intake is pure water, and the rate of the intake is 10 liters per minute. So we can say that will be our RI. So that's 10 liters per minute. And then the solution is kept thoroughly mixed and drains from the tank at the same rate. So it drains and drains from the tank at the same rate. So therefore, we can say that Ri is just equal to Ro. Okay, so it enters at 10 liters per minute. It also drains the tank at the same rate, which is 10 liters per minute also. And then how much salt is in the tank after 20 minutes? Therefore, we are required now to find how much salt is in the tank. Again, salt. So we are looking for the amount of salt, and then salt is a solute. Therefore, we are looking for the amount of solute. So this must be in kilogram after 20 minutes. So as you can see, we have 10 kilogram of dissolved salt, and then pure water enters, and then of course it drains at the same rate. But as you can see, pure water enters. Okay, so only pure water, so 100% water. But the trunk is draining what? It's draining the brine with some salt in it. So analyzing the problem, we should get less than 15 kilogram of salt. So that must be our analysis. If we analyze a problem, so the final answer must be less than 15 kilogram of salt. Okay, this one. Okay, so with that, let's analyze which case is this. So I can already tell that this is case one. So going back to the previous one, to the previous slide, so you can see that this is so for the solution. So analyzing which case this was. So you can see, as you can see, this is Ri must be equal to Ro, right? So we have the rate in and rate out and the same, and the intake is pure water. Okay, pure water intake. Therefore, this is case one. And then the formula for case one, we already have that. So for the formula for case one, that is x must be equal to xo e raised to negative r RO or RI, it doesn't matter because RO and RI are just the same, times T. Okay, so all we have to do is just direct sub. Okay, so substituting this, you'll have XO is 15, right? And then E raised to negative, RO is 10, and then the volume is 1000. At how many minutes? After 20 minutes. So this is minutes, and then the liters per minute also. So you don't have to change anything with the um, units. And the answer for this one, that is 12.281 kilogram. So I already solved this beforehand. Okay, so this is how you use the formula for case 1. So with that, let's go to the next problem. Okay, so let's have our next problem. We have in the tank of 100 liters of brine containing 50 kilogram totally dissolved salt again. So pure water is allowed to run into the tank at the rate of 3 liters per minute, while the brine runs out of the tank at the rate of 2 liters that's per minute. Okay, per minute. The instantaneous concentration in the tank is kept uniform by steering. That simply means that the tank is kept steered. Okay, all throughout the time. And then how much salt is in the tank at the end of 1 hour? Okay, so let's again take note of all the givens that we as much as we can. So we have here given. So we have 100 liters. As I said earlier, liters is a unit of volume. So we can have 100 liters of brine containing 50 kilogram of totally dissolved salt. So we have, again, salt will be your solute. Therefore, that will be the initial amount of solute, which is 50 kilogram. So pure water, so take note of that. That is a pure water intake at the rate of 3 liters per minute. So we have Ri. So that's the intake, or the rate intake of the water. That's 3 liters per minute. So brine runs out of the tank at the rate of 2 liters per minute. So it runs out, so that will be your RO, 2 liters per minute. And how much salt is in the tank at the end of 1 hour? Therefore, we are required to find how much salt. So that will be your X. So again, this must be kilogram at 1 hour. At T must be equal to 1 hour. But remember, as you can see, Ri is 3 liters per minute, or Ro is 2 liters per minute. So they are in minute. And then your time is at 1 hour. So there are two ways to do this. Is either you make Ri and Ro into per hour so that the units are consistent, or you make the time 1 hour into minutes. So of course, it is way easier to make the time 1 hour into minutes. So 1 hour is also equal to 60 minutes. So we'll be using 60 minutes, not 1 hour. Okay. Okay, so let's try out now the solution. So for the solution, again, we have to know which case is this one. So as you can see, this is Ri and Ro are no longer Ri not equal to Ro, but the intake is still pure water. So pure water ang intake. So therefore, we can conclude that this is case 2. Okay, so this is case 2. So for the case 2, we have the formula. Um, X must be equal to XO times V plus V. No. Um, Ri minus Ro times the time V raised to Ro over Ri minus Ro. So this will be the formula that we will be using for this one. So with that, let's just direct substitution. Let's do direct substitution. That's XO is 50 times V is 100, right? So this is 100 liters plus Ri is 3, Ro is 2, and then T is, again, this must be 60, not 1 hour. It must be in 60 minutes. So this is 100 all raised to Ro is 2, Ri is 3 minus 2. And then if you put this in your calcu, the answer will be 19.5313 kilogram. So this will be your answer. That means after 1 hour, the 50 kilograms salt will only be 19.5313. And then I think that's it. And then let's go to our last problem. Okay, so having our last problem, we have a tank contains 60 gallons of a solution composed of 85% water and 15% alcohol. And then a second solution. So we have a second solution containing half water and half alcohol is added to the tank at the rate of 4 gallons per minute. So at the same time, the tank is being drained at the same rate. Assuming that the solution is stirred constantly, how much alcohol will be in the tank after 10 minutes? Okay, so we have a tank that contains 60 gallons of solution, and then that tank and that solution composition is 85% water and then 15% alcohol. Now there's another tank or another solution or this is the intake. So the solution intake is containing 50% half water and then 50% alcohol. So half half is added to the tank at the rate of 4 gallons per minute. And then at the same time, the tank is being drained at the same rate. So we have Ri is equal to Ro. So assuming that the solution is stirred constantly, how much alcohol will be in the tank after 10 minutes? So as you can see, we are asked again to find the amount of solute, which is the alcohol. So let's put all the givens again first as much as we can. Okay. So we have 60 gallons, so that will be your V. Okay. So 60 gallons, and then that is composed of 85% water and then 15% alcohol. Therefore, we can get XO, right? So XO will just be if the 60 gallons, that is 85% water and 15% alcohol. So we can get the XO. So as water will be your solvent, solute is the 15% is the alcohol, 15% alcohol. Therefore, if we want to get the XO or the amount of solute, initially, all we have to do is get the 15% of the 60 gallons. So getting the 15% of 60 gallons times 60 that is equal to, so that will be 18, I think. That's right. Okay, just reading my calculator. That will be point 15 times 60. No, it's 9. Sorry about that. So that's 9 gallons. 9 gallons. So this will be your for the solute. And then a second solution, half water and half alcohol, is added to the tank at the rate of 4 gallons per minute. So so we have Ri is also equal to Ro, right? At the same time, the tank's being drained at the same rate. So Ro equal to 4 gallons per minute. So assuming that the solution is stirred, how much alcohol will be in? Okay. So we are required to find now the amount of alcohol, or X. So this must be in gallons at T equal to 10 minutes. Okay. So let's now have the solution. So solution, as you can see, Ro is still equal to Ri is equal to Ro, but the intake is no longer pure water, not pure water intake, because the intake or the second solution added to the 60 gallon is a half water and half alcohol. Therefore, that is a 50-50. Okay, so therefore we can say that this is case 3. So using the formula for case 3, so writing that down, we have T equal to ln, um, I think I forgot to mention the CI. Okay. CI, what is CI? And VCI minus XO raised to negative V over R. So that R is either RO or RI. It doesn't matter because the value are just the same or equal. Okay, so we are looking here the value of X. Okay, so what is CI first? Remember that CI, note that CI is the concentration of solution intake. So what you mean by concentration is the percentage, okay? Concentration of the solution intake. So I'll just highlight that out so that you guys can see. Okay. So as you can see, CI is the concentration of solution intake. So in this case, we can have that CI, can add it here. CI is equal to 50%. Of course, we will not use the 50%. We'll be using the decimal form, which is also equal to 0.5. Okay. Okay, so with that, all you have to do is to direct sub the value. So T is 10. So this is 10 must be equal to ln. And then V now is 60 times CI now is zero point 0.5 minus X is the one that we're looking for, the required. And then this is again 60 for the volume times zero point 0.5 again minus 9 raised to negative 60 over R. R is either Ri or Ro, so this is 4. This is 4. And then all you have to do is just solve for x. So solving for x, you'll have here getting the e of both sides. You'll have your e raised to 10, okay? And then ln will be cancelled. So that's 30 minus x, and then 30 minus 9, that's 21. This is all raised to negative 15. Negative 15. Okay, and then next step is we can have raising both sides by 1 over negative 15. So you'll have here e raised to 10 over negative 15 equal to 30 minus x all over 21. And then cross multiplying, you'll have your 21 e raised to, that's 10 over negative 15, that's negative 2/3, right? All equal to 30 minus x. And then transpose negative x to the other side, transpose 21 e raised to negative 2/3 on the other side also. So finding x, you'll have here 30 minus 21 e raised to 2/3. So let's try inputting this in our calcu. I think the answer will be 19.2182. So the answer is 19.2182 gallons. So this will be the final answer. That So as you can see, we have initially 9 gallons only, but as you can see, we have 15% alcohol initially, and we are draining 15% alcohol, but we're adding 50% alcohol. This one, so we are expecting a larger amount of alcohol after 10 minutes. So I think that's it. That's the cases. That's the three cases that I know, and the formulas are already here. So I think with that, so again, I really hope that I was able to help you guys with your lessons, especially during these online classes. So if you have any question, of course, feel free to comment it down below. I'll be happy to answer all your questions. I'm reading all your comments as much as I can. So if Of course, don't forget to subscribe to my YouTube channel, and of course, hit the bell notification so that you'll be notified as soon as I upload a new one. I want to thank you all guys for watching. Have a great day, and I'll see you on the next one. Bye bye.